Hi everyone. We're starting a new unit today, Unit 8, um, quadratic unit. It takes up pretty much the rest of the year. We divide it into two pieces. The first uh, piece of the unit is going to feel like a lot of skills. The second piece is going to bring in the applications. Today, it's going to feel like a really big vocabulary lesson and with a little bit of adding, subtracting thrown in at the end. So today we're going to do adding and subtracting of polynomials. It's chapter 9 in your books, section 1. But first of all, we have to get some vocabulary under our belts. So first of all, a single algebraic expression that is a number or a variable or a product of a number and a variable or is called a term. And I've given a bunch of examples here. We've worked with terms throughout the year. There's a 3x, a 2x squared, negative 12xy, the number 7. Those are all called terms. Now, when you take those terms and put a plus or a minus in between them, we're going to have a new term, which is called a polynomial. Poly means many, and nomial is like another way of saying term. So if you have an expression that is either the sum of one or more algebraic terms, and again, subtraction can be the same thing as adding a negative, you can have a number in front, a coefficient, like the negative 4, and our exponent here is a non-negative integer. Let me explain what that means. So polynomials, by that word non-negative integer, the integer part says there can't be any fractional exponents. So we're not going to have any roots. We're not going to have anything that looks like this guy. That's why he's got a red oval with a line through it. That is not a polynomial. The other thing that polynomials can't have is a negative exponent, which means that we're not going to have a variable in the denominator, like x to the negative 1 would put this guy in the denominator. So all of our exponents are going to be positive integers, or they could be 0, because that would give us just a number without a variable. So that's what a polynomial is. It's a many-termed expression. And now we're going to learn a couple more things. So first of all, I'm going to go down here, and you're going to look at this one right here. And this one is in what's called standard form. Now, standard form of an equation is where the terms are placed in descending order from largest degree to smallest degree. So let's just stop there for a second. What does this term degree mean? The degree is the exponent of the variable. So if you look here, we have the x to the third in front of the x to the second, in front of the x to the first, in front of the constant. And remember, the constant could have an x to the 0, which would be 1. So all of our exponents are going in descending orders. So that's what it means by largest degree to smallest degree. And we have no terms that have the same degree. So if you look here, there's a 3, there's a 2, there's a 1, and then of course this would be the 0. Now, if you look up here, there are two examples that are not in standard form. So look right here, they're going up in order rather than down, with the x squared being at the end. You'll remember I always say let the constant be the caboose. I kind of had my eye on this when I was saying that to you. And if you look over here, this one also is not in standard form, because look at these two guys. They have the same degree. They're like terms. We should be combining those. 6x minus 3x would give us a 3x. So just to remind you that that little number is called the degree of the term. Now, the degree of the polynomial will be the largest exponent. So this would be a degree 3. And the leading coefficient of the highest exponent is called, the leading number is called the leading coefficient. So there's the leading coefficient. It would be 4. This one is in standard form. The degree of the polynomial would be the 3. And oh, by the way, the constant is the caboose. So standard form, make sure your exponents go down from largest to smallest. That's called the degree. The degree of the polynomial is the biggest exponent, and the number in front is called the leading coefficient. Now we're going to start naming these guys. So here comes some major vocabulary. So if your highest exponent, so look at these two, they're both don't have a variable, which means it would be an x to the 0, no variable. Those are called constants. No surprise there. If your highest degree is an exponent of 1, so x to the first here, x to the first there, that is called, oops, let's put that back. Sorry about that. There's the box. It's called linear. Think of y equals mx plus b, right? The x had a degree 1, had an exponent of 1. Now, if we look at our largest exponent, notice this guy is in standard form. Notice it's a 2, and it's a 2 here. We learned this back in our function. That is the quadratics, and that's what we're going to be working on in this unit. If we take our highest degree on the variable of being a 3, notice it's a 3 here. You might remember this name from our function families. It's a cubic. Now, your book doesn't have the next one, just to let you know, but if there is a 4, it's called a quartic. And if you think of 4 quarts of milk in a gallon, that might help you remember. And then once we go past the 4, we don't have special names. We just call them 5th degree, 6th degree, 7th degree, that type of thing. So that's kind of like giving the polynomial a first name. But of course, we can also have a last name. So you're going to classify, you're going to name it by degree, which is what we just did here. But then how many terms are there? So notice there's one term in both of these. Notice there's 1, 2, x and the 5, or the x squared and the 9. There's 2 terms. Down here you see 1, 2, 3. Remember, the terms are separated by either additions or subtraction, and there's 3 over here, and there's 4. Now, this was kind of like their last name. So if they only have one term, they would be a monomial. If they have 2, and think about mono means 1 for a prefix. What would be a prefix for 2? Think of the thing that you ride that has 2 wheels. It would be a bicycle, so binomial. And then, of course, a little kid would be with 3 wheels. It would be a tricycle, which would be a trinomial. And then once we go past 3, we pretty much just label them polynomials. So what I'm going to show you in the next slide is how we put the 2 names together. So let's take a look again. Look at this guy. He has what degree? He is a degree 0. He doesn't have a variable, 0 variable. If it was there, it would be x to the 0, and it would become a 1. So his degree name would be a constant. How many terms are there? There's just 1, so he's a constant monomial. Down here, we have an x to the first, so his degree is a 1. So by his degree name, his first name would be linear, and there's only 1 term, so he would be a linear monomial. 7x plus 1, the biggest exponent is 1, so that's the degree of the polynomial. There are 2, oops, sorry, I forgot to give you his name. He's linear as well because his degree is 1. And then there are 2 terms, so he would be a binomial, so he is a linear binomial. The degree of this polynomial, the biggest exponent, is 2. His degree name would be quadratic, and he has 1, 2, 3 terms. He's a quadratic trinomial, and that is going to be something we're going to work a lot with coming up in the future. Highest degree is a degree 3. His first name would be cubic. How many terms does he have? 1, 2. So he's a cubic binomial. Highest degree is a 4. This one is not in the book. He would be named a quartic, and we are beyond the trinomial, so we would just call him a polynomial. I'm just going to throw this last one in. We really don't work with it in Algebra 1. You will see it in Algebra 2, but if you have multiple variables, you would kind of just add those 2 together. He would be at what's called a degree 5. We would just call him a 5th degree, and once there's more than one variable, we would just call it a polynomial. So what I'd like you to do right now is pause the video and see if you can name the 4 at the bottom of the screen, giving their first name based on degree and their last name based on the number of terms. Come right back and see how you did. Okay, everybody, let's see how we did here. Highest degree is a 1. So he is a linear. 2 terms would be binomial. He's a linear binomial. Highest degree is a 3. He would be a cubic, one term, cubic monomial. Highest degree is a squared, so he'd be a quadratic, 3 terms, quadratic trinomial. Highest degree is a 5, so he's going to be a 5th degree, and we're beyond the trinomial, so he's just a 5th degree polynomial. How'd you do? Okay, so now let's add a little bit of math in here. We're going to talk about adding and subtracting polynomials. Adding is the easier one. So if you look at this first addition we're going to do, there are 3 polynomials here. None of them are in standard form. It's kind of a hot mess. You can see here that they're out of order. Here they're out of order. See, they're all kind of out of order. But we're going to add these 3 polynomials. And when there's an addition in between, the parentheses aren't necessary, to be perfectly honest. Now, what we need to do is we need to find the sum, we need to add them, and then we need to write our answer in standard form. So the way that I like to do this is a Woodruffism, is I do them in order. So I find the highest exponent in here, which is going to be to the third. I have 4x to the third here, and I'm looking for other x to the thirds, and you'll notice way to the back is a minus 1x to the third. So I have 4x to the thirds, take away the 1x to the third, which you can write it as plus a negative x to the third, whichever you like. And if I have 4 and a negative 1, I'll have a coefficient of 3 x to the thirds. Now remember, our exponent isn't going to change when we add or subtract. It's only when we multiply or divide will that change. We're looking at 4 of these plus negative 1 of these is 3 of them. It doesn't change. Now I'm going to move on to the next smallest exponent. So I'm looking for a, up here a 2. There's the 5x squared. Adding a 3x squared. So right now I have 8x squareds. Any more? And another 6. So the 8 plus 6 would give me a 14x squared. And you can see me writing it out here, which you are welcome to do if you need to. But if you can go through and kind of add left to right and do what I'm doing, that's fine as well. So now I need to look for x to the first. So there's a negative 1. No. And a negative 4. Negative 1 and negative 4 would be negative 5x's. And that's it. And you'll see it right there. Now again, minus 5x or adding a negative 5x is the same thing, and you'll kind of see me writing it here. So now I'm down to the constants. So I've already done all these up. 9, take away 2 would be 7. Take away 8 would be negative 1. There's the minus 1 or adding a negative 1, and you can kind of see me writing it here. So if you can go from here to here directly, that's fine. And if you need that intermediary step, feel free to do it. Now your book talks about doing either the horizontal method or the vertical. So I'm just going to show you the vertical. It's not my favorite, but that doesn't mean you might not like it. So the first thing you do is you put all of the polynomials, the 3 of them, in standard order, and you kind of put them on top of each other. So you line up all the x to the thirds, all the x squareds, all the x to the first, and all the constants, and then you kind of just add down. So 4x and a negative x to the third, 4x to the third, take away an x to the third will give you 3x to the third, and there's the 5 plus the 3 is 8 plus 6, there's the 14x squared, and a negative 1, and a negative 4 makes a negative 5x, and 9, take away 2 is 7, take away 8 is negative 1, and you're seeing we're getting the same answer. Now your book in the directions will say use a specific method, throw that direction out, use whichever one works for you all the time. It does not matter to me. So use your favorite method. So let's just talk about subtracting. It's not that different, but it is the tougher because the parentheses matter. So here is a polynomial, which happens to be in standard form, taking away another polynomial. When I go to subtract this second polynomial, I am not just subtracting that first term, I'm subtracting everybody. So I'm going to take away a negative 2x to the third, and minus a negative becomes a plus. I'm going to take away a positive 6x, which would give me a minus 6x, and I'm going to take away a negative 8, and minus a negative gives me plus 8. So basically, everybody's sign in this second polynomial is changing. And then once I do that, the parentheses aren't necessary, and we go right back to doing the adding. So remember, the Woodruff method is to look for your highest exponent, which is the third. So I got negative 2 of them and a positive 2 of them, and that's it. So I'm going to have 0 of them, so that drops out of my answer. There's no x to the third. Now I'm going to look for my squared, 7x squared minus 6. Whoops, no, I'm sorry, there isn't one. So he just drops down in the answer. I almost got caught there. Negative 1, take away 6. So negative 1x take away 6x, you can see it right here, is negative 7x. And then 15, add the 8, would be 23. The number one mistake is right here, to put a plus 6x and a minus 8, to only subtract that first term. So here are 3 for you to try yourself. So pause the video and give it a go and come back and we'll see how you did. Okay, let's check out how you did. So the first one I see, I'm going to go for that squared. Negative 8, adding positive 1. So did you start it off with negative 7m squared? Remember, your answer needs to be in standard form. So now I'm going to go down to an m to the first. There's 2 of them here, adding 5 of them there. You see 7 of them. And it looks like the minus 3 is just there with nobody. Okay, the next one, be careful. I'm going to take 2x squared and take away an x squared, leaving just the x squared to start. Negative 8y minus 5y. Negative 8 minus 5 is going to give me a negative 13y. And this one's going to get a little tricky. I got a negative 3 minus a negative 10. And when you have a minus a negative, that becomes plus 10. So negative 3 plus 10 is going to give me a positive 7. So to be honest, these parentheses aren't necessary, but these are, because you're going to subtract a 5x to the third, you're going to subtract a 3x, and you're going to subtract an 8. So 9x to the fourth is by himself. Negative x squared minus 6x squared is negative 7x squared. He's right here. I went out of order. The x to the third minus 4x to the third is the negative 3x to the third. And a 7x, add it to a 2x, would be a 9x. Take away the 3x is where the positive 6x is coming from. And a negative 9 minus an 8 gives you the negative 17. So hopefully that got you started with some really solid vocabulary about naming polynomials and then just adding and subtracting. I guess the thing I want you to remember about that is when you're adding or subtracting, make sure you realize that the exponents don't change when you add or subtract. And when you're subtracting, make sure you subtract everybody that's in the group that follows the subtraction. Other than that, it's pretty easy peasy. So good luck with this, and I'll talk to you soon. Thanks, guys.